Right, I'm back. I realized that my recording program wasn't picking up these windows and any other I don't think it picked up the click dialog here, just from looking at the previous videos, or any modifier whatever windows here. You weren't missing anything overly important. It's just mainly move options. Anyway, and hiding and showing things. So I finished the new speaker models just so we can see how it looks, and the posts. I moved the two posts that were over here to over here. Reason being is it might be a bit squishy having two terminals there pressed up against this magnet. I haven't bothered to design or draw in a pivot here. I don't know what I'm going to use in the end. I might just bend the metal and screw it directly on, or I might buy a pivot of sort or something, like a monitor mount or something. Anyway, I'm also using a new mic, and I set up, because when I played around with the software to get it working properly to show these windows, thought might as well pull out my good microphone. Haven't made many changes to this. One big change, just to see how it looks, is I combined, let me grab it. So these 4 panels, I combined them into one. I'll just hide that for now and show the new one. So now that they're all combined, the texture applies a bit more evenly. So it looks a bit more how it will look when it's finished, hopefully. But yeah, those are the major changes. Any other changes will probably just like changing the radius or thickness of the thing, chamfer a little bit. Nothing too important. Now I did some recording before of getting this all set up for a computer-aided machining setup, but of course my microphone wasn't picking up on it, so it was audioless. So I'm just going to go through that all again. Hopefully I can do it a bit quicker this time, because the last video was an hour. Anyway, so all I've done, I'll just hide all this and just show from the start what I've done. So this is the sheet I have in the shed that I can work with. 6mm MDF sheet that is 750 by 900mm. So all I've done, if I re-enable these again, all I did was copy all these sheets, panels, should I say, just Control C, Control V, and reorientated them so they were flat. One easy thing to note, so you're going to have them all at different heights like this. So once you've got them all flattened down, what you do is, now it's under here, you can just align it. You want to align that surface to that surface, and just do that for every object, and that'll suck it down to the board that you have. Then I just go into orthographic mode and top view, and then I can do some Tetris essentially and pack these all in together to get it to roughly the shape I want to cut out. Now I'm going to use a CNC machine, so the more tightly packed this stuff is, the better. If you're going to cut it using a table saw, then you just simply want to, you can just use ruler, get these measurements like this here, and just cut it out manually by hand, jotting all those measurements down onto a list. And it's up to you to figure out how's the best way to cut all this on a table saw. Obviously you can't get this sort of shape easily, but you can obviously just do a square section, because this here is just for beauty, this little overhang, so it's not of any importance. And obviously your rounded edges would have to be filed out, and your circular area will be just, you can just cut it out with either a proper hole saw, or if you got something, or an adjustable hole saw, or a router with a circular cutting jig. I won't go into depth about that, but I'm going to use a CNC machine. So the most important things is to get it all packed in nice and close. To figure out how you're going to mount it, I'm just going to use double-sided tape, so I don't have to worry about spacing for clamps or even tabs, since I can cut all the way through. I don't need tabs to keep it mounted to the main board. What I do need to be concerned about though is the size of the bit I'm going to use to cut. I need to make sure all these bits are spaced out big enough, not just for the bit to go through, but to leave extra padding, because I'm going to do a quick cut to leave a millimeter of MDF, and then I'm going to do a beauty cut right up against the actual geometry I want. And that beauty cut will hopefully leave me not having to do much sanding. So you do all that, you space it out, and you probably hide this sheet because I don't need it anymore. Then the next step you want to do is go into, now this used to be CAM or computer aided machining, but now it's manufacture space. So you just go into manufacture space. I've already done this all, so this will be quicker for you anyway. What you wanted to do, to pretend none of this is here, you want to click setup, and that will give you a this dialog here. All you want to do is you click your model here, or if it has anything pre-selected, get rid of it, press the X, and then just select all the panels that you're wanting to deal with in one big go. You can add a stock if you want, I don't bother, I just get rid of it all, set it to 0. The most important thing is to set up the axis of this for your CNC machine. So by default it chooses this sort of funky axis here, which is not what I want. Yeah, it'll go model orientation by default. So I want to select Z and X axis. So Z axis, obviously there's your up plane. Your X axis, I just select either of these faces. And your stock point, so this is where your 0 position is going to be essentially. So as the router starts moving a bit this way, it's going into to negative Y, I think, because this direction should be positive. So I put it over here. It doesn't really matter too much, just as long as you set this sheet up on the CNC machine and these axes are aligned with how your CNC machine operates, and you set your 0 to around here. So on the top of all this sheet, and that should all be set. Now obviously you want a little bit of padding here and here on the MDF. What I might do is just go to stock. So on the side offset, let me just add an extra 10mm. So there we go. So there's your padding, and there's your origin on the stock. I'm not going to bother adding height because the sheet is exactly that thick. So the next step we want to do is all these operations. First one I just start off with is under 2D, and it's just a 2D contour, which is this one. Now you select your tool, but setting up your tooling, your speeds and your feed rates, it's all up to you to know what your machine can handle and what your tools can handle. So I have like carbide bits which can handle a fair bit of heat, so I can run them nice and fast, and they're really strong and put a fair bit of pressure on them, even though I don't usually. So I've got like I've got a library of all the bits I have here, but here's the ones I've already set up. So what you want to do first is you select your geometry, which is just going to be these base flat areas, all these edges, preferably not the top. Doesn't matter too much, because what I do is I set the height, from your selected contours. So if you have selected contours in your bottom height there, then it does matter whether you select up here or down here for your geometry or contour selection, sorry. So if you want to be absolute, I just select stock bottom and negative. I'm just going to use 1mm actually. So what that negative 1mm does, as you can see here, is going to cut 1mm below the actual stock bottom, which means when I put this on the machine, I'm going to need a little bit of sacrificial board underneath, because it's going to cut into that. The second important thing is under linking here, I have ramp set, and I have a maximum ramp set down of 5mm. So what that means is the cut is only going to be doing 5mm depth at a time as it slowly spirals down until it reaches the final contour. Another thing to note is so you have like your normal cutting feed rate here, which I've got set relatively fast because it's a shallow cut, just quickly churn through it. And your ramp feed rate is different to your normal cutting feed rate. And your lead in and lead outs are also different. But leave plunge to something slow just in case you make an accident. Your lead in and lead out are, I have them disabled for this actually, so I'll talk about lead ins and lead outs later. Okay, the second important thing was under passes, I have a little bit of stock left. So axial stock is your up down height, and radial is your, well, pretty obvious, the radial distance from the bit that you can leave. So I'm leaving 1 whole millimeter because I'll take that away with a beauty cut, because the beauty cut, if you're taking away too much material, your bit's gonna deflect, or mainly deflect, and you might not get a straight enough cut. The second option here is the beauty cut. So I have the same bit, but I have a much faster speed and I have a slower feed rate. What that's going to do is the bit's going to get hot for starters, but my machine can handle that. It's well ventilated, and the bit is carbide with a heat coating on it. And usually what I found is this combination of high speed and an all-in-one depth cut leaves a real smooth finish, and it sort of gives you a new grain, because it will help heat up that wood and help flatten it over in the direction that the thing's traveling, that the bit's traveling. It depends on your MDF too. If you have new MDF that's relatively dry, it should do the job well, but if you have old nasty MDF, it's probably not going to do you any good. I've selected the exact same geometry as the ramping bulk cut. The big difference is let me reset this. So yeah, I'm still cutting past the bottom of the stock bottom. And under passes, there's no stock left. Uncheck that. So it's going to cut the exact dimensions I have here. Hopefully, depends how much deflection your machine has, and a bunch of other things. Our second most important thing under linking here is your entry positions. So this option, entry positions here, you can see there's a little point there, a little point there, one there, two in these corners. So what I'm doing is I'm aiming for a corner. So what's going to happen is the bit's going to slowly ramp in here, and then when it comes all the way around here, it's going to slowly ramp out. So if you do this on a flatter surface, if you enter cutting right up against your geometry at a flat surface, there's a chance you might get a bit of an unwanted groove embedded in here. The lead in and lead out helps stop that. Now, something important to note is I've adjusted the leads. They're not default. Usually they were 90 degrees. If I set this to 90, you have this sort of unnecessary big lead in, and what that will possibly lead to, or what it definitely led to around here, was there's like a plug of wood left here once it cuts out this sort of circle. So what it's going to do is, here, let me simulate this. You just fast forward. So what the bit does is it plunges down here, and then it starts its lead in, and it goes all the way around, and then it leads out and harshly cuts straight into this and then pulls up. Let me show you, I'll show you the actual thing. Right, well, you saw it punch in. Oh, God damn it. Can I undo it? Yes, I can. Awesome. You see how it just punches straight through there, which you don't necessarily want. Oh my gosh, why is it so slow? You get the point. So ideally I want to set this as small as possible, but still have that shallow entry. Where it's really beneficial is this big smooth area here. So I'll set this back to, was it 20 or 10? No, I think it was 20. See, it's a much shallower entry there, but you're still going to get the benefit of that slight curve will much lower the chance of getting a unwanted groove cut in there when it enters and exits at the same spot. So another thing to note is so you have your vertical lead in set to something. I usually set it to 0 because I don't need it. And your linear lead in is set to something. I set it to 0 again. And this is usually set to a small value, which is fine if you've got your 90 degrees. But since I'm using a real shallow angle, I want a bigger linear radius. So I set it to something bigger, 6mm. So do that for anywhere where you have a big lead in. So that cuts out the bulk of these materials. So I'll simulate, I'll just fast forward to the end. So voila, you don't have any unwanted big cuts in these plugs. So you've got mostly controlled initial ramp entry that gets rid of most of the material. Then you have a nice clean edge cut which just takes away that final little layer. So this is the bulk of our shape. This is just a boring operation. Oops. So under here there's bore. It's using the same 6mm bit. It's a little bit slower. There you go. I think it's using, I don't know, does it use ramp or plunge? One of those two. I've just selected those whole geometries. One thing you need to note, the hole needs to be bigger in diameter than the diameter of your bit. I haven't changed heights at all or passes. So this has lead-ins, but just leave it by default. It does a good job at figuring it out. You don't really have to set anything for this. And that'll just, you can see the little spiral as it goes in. So that's what that process will do. So that covers those basics. The next, there's like a pit here that needs to be, a pocket, sorry, that needs to be cut out. So I'm using a wide surface bit. So I'm using a bit slower speed for it because it's a much wider cutting area. The rotational speed's still high. So the geometry, I'm still using a contour, 2D contour, which automatically figures out how far away the bit should be to cut up against this surface. But it's also doing a good face cut here just automatically. So that geometry is selected there. Haven't changed, just make sure you don't set an offset here because you want to cut flush with that. There's no stock left. It's just a direct cut. It usually does a pretty good job, and it's going to be hidden anyway by the tweeter. One thing to note, sometimes in case you get different speed, you have finished speed here under your passes, and you can have your different cutting speeds under here. Sometimes they might be different, but usually if you just set them all in one area, it'll synchronize it all. Now under linking, I've enabled ramping and a minimal cut depth of 1mm, so it's only going to cut at any depth 1mm at a time. And once again, I've got the same lead set in, the shallow lead angle. I have a slightly bigger linear distance. So if you let that run, you can see that path looks pretty good. So if I simulate this, just go to the end. Yep, looks nice. We don't worry about the plug because that's just going to come out in the end. Now the next process. Now these chamfers, they can be cut just by a router and using a guide bearing just to trace through there, but I might as well use the CNC machine. It'll get it perfect every time. So this is pretty much, this is a 2D contour as well. You can use chamfer, but 2D contour is pretty much the exact same thing. So I have a big wide bit for it. As you can see, big cutting surface. So that'll easily be able to cut this and this wide area. Decent speed, rotational speed, relatively slow cutting. I want it to sort of give a smooth, powdered cut, so I have to do minimal sanding. I can probably get away with no sanding once it's all done. I just have to see. So geometry is the bottom of the circle. Don't have to do anything there, don't have to change heights. Under passes I have to change something. So chamfer, I want to set a bit of an offset, because you don't want to be cutting, oops, where's the, that's gone. In short, you don't want the very tip of your chamfer bit cutting on the very edge of your angle. It's just going to leave an edge which you don't want. So what that'll do is, you see how the cut center here is now offset from this 45-degree angle. It's pushed down a bit. So your center of your cutting bit's going to be here, so you're not going to get any ugliness. Now this spirals down as well. Yeah, so it uses the same ramp. It's only ever going to be cutting 2mm of depth at any time. Keep in mind it's a wide, the bit has a wide cutting area, so you don't want too much of a cutting depth. The leads, I've used the same shallow angle. I've changed it with a nice big lead in, and the lead in linear, distance is 0, and the vertical is all 0. Now the reason why I have the ramp, because if I didn't, it'll just come right down and cut out a cross-sectional area that is that big, which is probably, it would be a bit harsh for this. It's only a 6mm shank. It's not 12mm or anything harsh like that. So I'll show you a simulation of that. So I'll show you what I mean by the it's only cutting a small amount at any time. So you see now it's digging in. I'll speed that up. See, it's slowly eating away at the material. It's not taking out this massive chunk in one go. It's slowly spiraled out. And you can see there's only the most minute of nibbles in the plug once it retracts out with the lead. God damn it. Okay, so the next thing is I'm doing another slight contour just on this little edge here, and just on this edge here, just to clean it. This edge is never going to be seen, but I might as well clean it in one go. So same speeds and everything, same bit. Geometry is the bottom of the hole. So I've got that same offset here. I've actually enabled a bit of stop to leave just because I'm too lazy to adjust the geometry, so I'm adjusting my cut here. So this is going to cut a little bit higher than it should, because I've realized this was probably too big of a radius compared to what's on the tweeter. I want the radius here to match what's on the tweeter. And same lead in, shallower angle, larger horizontal lead in, and 0 and 0 for these two values. So far I'll show you a simulation. I'll just cut right to the end so we can see how it looks. See how it's a sort of a narrower shape there. The quality of this looks horrible, but that's just the software. It won't look like that in real life once it's actually cut. Now I'm just checking to make sure there's no unwanted grooves from a lead in or lead out. I don't see any. So this has done a pretty good job. Now we're not 100% finished because I want to cut this chamfer, and I will save it just in case everything crashes. So doing this chamfer is going to be a bit difficult because I've had to add a radius here, didn't I? So I'll show you why it's going to be difficult. Yep. So I'll add another 2D contour. I'll select my same big chamfered bit, and all those default values should be alright. So geometry. Now this is the problem. It's classified this whole area as one big, and this area as well, so I can't just use offset. It's all crazy about. Now if I do select this, I'll show you what it's going to look like. So we'll just use default settings for now, and I'll run the simulation, just do everything, and I'll hide the original geometry. Now do you see what's happened here? It's cut this pretty well, but it's also cut this because it was following this edge, which we do not want. Turn the geometry back on. You see it's labeled this as like a 2D plane, and it's going all the way around here. Now there might be options. Nope. I'm just going to try 3D. See if there's something simpler that I can get away with. paralleling. I'll just try this the old-fashioned way. So I go back into design space, and one way I can tackle this, select this face, do a sketch. So just press L for line, and I've selected this surface. I'm just drawing a whole line there. Finish sketch, and select this other surface, press L. So that's enabling a sketch mode. Now I probably actually want to be careful here. I probably want the line to terminate roughly there, because what's going to happen is it's going to follow this line, and I don't want it cutting into this surface. If it does, I'm going to have to move this geometry up a bit. So I've got to adjust this. So just press M, and I can move this without entering the sketch mode, which is a handy feature. That might just miss this edge. Might as well push that in. That's a bit too far. Go. Now if I go back into manufacture space, and it kills all these, don't worry about that. So I'm going to do the contour again. Actually I could use trace, but I'll try contour because it will allow me to add an offset, whereas trace won't. Yep, that's got it selected by default. So now I can use sketch as geometry. Notice this little arrow that shows the side of the geometry, or the side of the selection that it's going to do any pushing on. By pushing I mean offsets and stuff like that. So if you click it, it'll swap. So I want it, I'm pretty sure that means this side is going to be where it pushes out towards, which is what I want. And I'll select this, which is selected the right side. Now chamfer is what we want, so I'm going to enable my slight offset again. Don't want any stock. Linking. Now we don't really need any lead-ins or lead-outs with this. So let's just see how that goes by default. Yep. So you see how it's offset from the line by the appropriate amount and the appropriate angle. And what I'll do is I will regenerate all these, because if you make the slightest change, it kills all your previous generated paths. So if we go to simulate and I just fast forward to the end, beautiful, it looks like it's done the right job. It's come close to here and here, but it hasn't cut into it. But as you can see, it's cut flush, it's doing its job. But I will add a ramp to this, because that is a lot of material it's cutting in one go. So I'll just edit this. What I will do, I will duplicate this. Actually, no I won't. I'll edit it. I'll add my ramp. I had 2 millimeters before as our maximum ramp clearance height. That's just how high above this geometry it's going to start ramping. So you could use 0 if you want, but 1 millimeter or whatever, it's fine. And there's a slight warning. Both ways. Not sure what that means. Anyway. So that's going to zigzag down. So the ramp feed rate, which is too slow here, I'm going to use 1000. So the ramp's going to be a bit faster, just bulk material removal. Then the pass finish rate, which is just going to be this one final pass at the bottom, which I believe is the same as this cutting feed rate. So that'll do 2 different speeds in one go. So if we I'll show you once again while we're doing the ramp. So it just slowly cuts away at the material instead of one massive chunk, which will be too much of a load on the motors and all the axis and that spindle, that shank mainly. So it slowly grinds down. Well, actually it'll be grinding down faster because our ramp speed is higher. And then it should do a slower pass, although it might not show speed with the simulation. So this should be the final cut. Yeah, it doesn't slow down, but it will slow down on the actual machine, hopefully. Because the color of these lines represents the feed it's using. So ramping is red. And once again, keep plunge slow in case you make a mistake. You don't want it plunging down at a fast speed. And this is a relatively high speed. Once again, I'm using carbide toothed bits. They don't care too much about heat. And the wood, it doesn't matter if it burns, it's going to be painted and it's MDF. But it shouldn't really burn because the whole thing is ventilated. There's lots of airflow over it. There's a big dust extraction system. And I was going to copy that same speed difference for this. So we want the ramp to be, here we go. So the ramp is very slow there. Set that to 1000 and the final cutting rate is going to be that slow speed. I'll bump you back up to 18,000 RPM. Alright. So we do a final simulation again. Make sure that all looks good. And it looks beautiful. One thing to note, if you click stop on collision and you play and fast forward, if it's gone all the way to the end and it hasn't stopped, then there's no unnecessary collisions, which is sort of important. You don't want unwanted collisions on non-cutting faces. Another important thing, which I'm going to have to worry about because I'm not sure of certain values. So it doesn't matter too much on the ramp because you're only cutting a few 5mm at a time there or something. I'm cutting, 5mm at a time. But for the beauty cut, which is cutting that whole surface in one go, I have to worry about the total cutting depth. This is 16mm plus 1mm undercut here. So 17mm I'm going to require of the full land speed. The lands being the cutting bits on the bit. Let me show you a simulation just to so this tool, the lands are going to have to come all the way up to here, all the way down to the bottom. And I believe I might have to double check, but when I measured my lands under the tool library, flute length, sorry, not lands. Lands are on part of the flute, I think. So they're 15mm, so I'm going to have a section which doesn't have a cutting face, which is trying to do cutting. But I think I undermeasured that, but I'll double check it before I actually do the cutting. Just something for you to note as well. I do have different bits that I can use anyway. Okay, keep that in mind. You need to have land lengths that are as long as the full depth that you're cutting. And of course you need to make sure the base of your spindle is not going to clout anything. Pretty basic stuff. I think that covers everything. What you should do is run through the simulation by eye, nice and slowly. Actually watch every single operation run through. But I won't take up your time doing that, just to make sure nothing unnecessary is getting cut. To make sure that bit is not cutting at excessive surface area, or volume should I say. Then once you're satisfied, just post-process and make your file. Anyway, yes, you don't need to see all that. I shall show you the next processes when I'm ready. Goodbye.